Hi, this is Wes Simpson with another edition of the Summer Sessions on Media over IP, brought to you by Ames and the VSF. With me today is Jean Lapierre, who is Senior Director of Software Engineering from Matrox. And he is going to be talking about ST2110 testing fundamentals. Welcome, Jean.
Thank you. Thank you for having me.
I'm glad you're here. I hope things are going well in your part of the world.
That's good. Can't complain right now. It's good. The weather's nice.
Well, good, good. So let's get started. So ST2110 testing fundamentals, obviously a very important topic. I'm very interested to hear what you have to say.
All right. So today in testing fundamentals, what we're going to cover is how to build your own test plan. Today in the testing fundamental, what I'd like to cover is how we can use the JT&M tested program as a basic for building your own test plan. So why would you need to build your own test plan? Well, if you're going to get a new device, I don't think it's a very good idea to connect it directly to your production environment without first making sure it's a good network citizen. After all, I think your boss is going to get pretty mad at you if you screw up everything on the production. And so maybe you also want to make sure that the device delivers as advertised. So maybe the salesperson told you, hey, this device does 2022-7, no problem. You might want to make sure it's really true before you actually need it and figure out it's not. Will it work with other devices? It's also important. So how do you make sure it works with all the different devices? Well, one way of doing that would be to make sure that the device conforms to the spec, follows the spec properly. That kind of gives you an idea that it's going to play nice with other devices. Maybe you just want to test and make sure that it's going to work with other devices you might get in the future. So if you do all your tests for this receiver based on devices you already own, that doesn't tell you it's going to work with devices you may get later. So the focus of this talk will be on ST2110 tests. So the JT&M program covers more than just ST2110. It covers NMOS ISO 4 and ISO 5. It covers TR 1001 and security. But here we're going to talk about the ST2110 test plan. So why do I think the JT&M tested program is a good place to start to do this? Well, first of all, it was created to answer the needs of the end users. The community wanted to know which device does what, which device supports what properly, how well does it work, and things like this. And so it's created for that community. There's an expert group that helped figure out what needed to be tested exactly. But it's administered by the EBU and the IRT, and this whole thing is not manufacturer driven. So with the help of the expert group, they figured out how to test ST2110. And what's neat is that it includes a simple pass and fail criteria, so you know the thing actually works or it doesn't work properly. They also, as a bonus, had identified tools that could be used to execute the test plan, many of which are free. And so where do you get the test plan? Well, the JT&M program has been running for a few years now. And for every event that they did, they published a catalog with the results. What's really interesting is the catalog includes the full test plan. So if you want to know what test plan was used for creating the catalog in 2019, you open up the catalog, you see the test plan there. So this talk is based on the latest event from the spring 2020. You can see the link where to go get the catalog. You'll see there all the spring 2020 catalog is there, but all the older catalogs are there as well. And so when you open up the catalog, as I said, you see the test plan, and the test plan include links to the tools that were used and references for the test plan. And so what is this ST2110 Plus cover? So it covers the general network interface tests, some tests that are related to the media network, and then it tests the various parts of ST2110, testing audio, video, VANC, -7 support, things of that nature. And so how do I propose you get started? Well, the first thing I think you need to do is you really need to build yourself a separate network from your production environment. I do not suggest you attempt to do these tests in your production environment.
Makes sense.
So yes, it does. Things can get bad.
Really?
So ideally, a setup that you build is going to be similar to your production environment. So what I mean by that is if your production environment uses -7 for redundancy, I suggest you build something that supports -7 for your test equipment. You're going to need access to at least one PTP Grandmaster, and I suggest you use a boundary switch because for some of the tests, it's useful. It's also probably a good idea that you get familiar on how to set up a monitoring session on your switch, because very often to do these tests, we need to capture what's called PCAP files, and that's done by instructing the switch to copy all the packets from the tested device to another port so you can capture the packets into PCAP files. So first up are the network connectivity tests. So the test plan wants to verify that you support DHCP properly, or that you can do static configuration of the network addresses. And then they go through a series of tests like pings and routing to verify that the device is using the network properly and can answer a ping from another subnet or things of that nature. That's very useful when you build a big network. Then they do these tests both for the management network, but also the media interface. And then we make sure the device supports multicast address properly. That was an ask from the community because some early devices only supported a very specific set of multicast addresses, and that doesn't follow what the spec asks for, and it makes configuring a big environment very difficult. So
Sure. Yeah.
they wanted to make sure that the test plan made sure that my devices followed the spec when it came to multicast addresses properly. Then there's some tests, basic PTP tests are done, making sure that the device can actually lock to PTP for a given domain, that you can change the domain, that the device is not hard-coded to working only, let's say, to PTP domain 0, and that you can set it and it actually works properly. Then there's a new test that got introduced in the latest test called PTP Grandmaster Failover test. Again, the community was saying, hey, we get these devices and they work properly, except when there's a failover, they glitch, and they shouldn't glitch. So can you come up with a test that verify that the device does that so we can see that in a catalog? And so the -10 tests that are done. So for a receiver, this is basically making sure that according to the spec, we should support IGMP v3. And maybe the environment you're in is an SDN-based environment and you don't really care about all this IGMP stuff. But I still suggest that it's important to make sure your device supports the spec properly, because even if you don't use it, you never know what might come useful. And this is basically done using Wireshark to spy on a device to make sure it's doing IGMP v3 requests and not v2s. And because when you have a network that's based on IGMP v3, if someone does v2, everything turns to v2, and it can be a big problem.
Yeah, it's a big deal. Yeah.
Yeah, so it's important to make sure they actually do v3 and not anything else. For the sender, the tests are surrounding the SDP file. So in the specification, the SMPTE specification, it says that if you're a sender, you need to generate an SDP file that describes your signal. And so there's a tool that got developed, it's a free tool that got developed to check that the SDP file is a valid one, that the syntax is correct. They also, the test plan also looks inside the file to make sure if it's a -7 signal, that it's described properly as a -7 signal, that the IP addresses that are inside the SDP file actually match the sender. They're not hard-coded SDP file. We've seen that a long time ago. This is something that we test to make sure it doesn't happen anymore.
That's a nice point.
And then I'm going to describe the audio, video, VANG test and timing test for senders as one test, but in the actual test plan, they describe individually for each part. But the flow is the same for all of them. So just describe them quickly. So for your sender, they tell you a multicast address and a port to program your sender to send to. And then if it's a -7 device, they ask you to do the same for the redundant flow. So, and then if you have a receiver that can receive the signal, you basically tune it to that signal and make sure you can receive it. But the meat of the test is really like the capturing of the PCAP file. And if it's a -7 test, you also capture the -7 signal. And then they take these files that are basically a recording of all the packets the device was sending, and they bring it into a software called LIST. And LIST is also a free software that got developed basically for our industry to do these very tests by the EBU. And LIST will open up the file and analyze all the packets in there and look at the timing of all the packets and compare them to the spec and make sure it conforms to the spec, that the timing is good, that there's no error, no missing packets, that all the timestamp are correct and all of that. And these tests are done and repeated for various video formats you want to test. So maybe you're doing a test for a sender in 1080i, but also in 1080p or UHD. For different audio profile, you can have like stereo, you can have like a 16 channel of audio. So repeat the test for these different things and for different ancillary data payloads. And for a receiver, well, you're going to need a reference sender. Basically, you need a sender that you know is sending a good signal. So identify one sender that you want to use, sending audio, video, VANG. And then you program the receiver under test to listen to your reference source. And then you make sure that it can listen it and receive the signal without disturbance. Unfortunately, it's not a very scientific test, but it's kind of hard to measure a receiver other than making sure it actually works properly. And so the secret here is to use a proper sender, like something that you can trust. So other tests that are done on a receiver are for -7. So for -7 as a sender, it's verified while we earlier in the test when we were checking the SDP file that the signal was there. It was done by capturing that sender and making sure that the -7 signal was present. For a receiver is where the work actually gets done, where we're talking about redundancy, right? It's the receiver that needs to be able to recover missing packets. And so the sender's job is pretty simple, send -7. So you need your reference to be able to generate a -7 signal. And then you program your receiver to listen to your reference. And then you play trick on your send or your receiver by turning off the signal on one side or the other side and making sure there's no disturbance on the received signal. And that would be like the basic test. It's pretty easy. It doesn't need anything special, and you should be able to do this in your lab fairly easy. Worst case, you just pull the fiber. That works. And then there's the seamless protection switching test, which is a little bit more sophisticated. For this test, you add a network emulator in the path, and you can use any network emulator you want. But generally, the idea is to generate some impairment. And at that point, the network emulator is able to drop packets. Instead of disconnecting the signal for seconds at a time, it can drop just a few packets on the main or drop a few packets on the redundant. And your receiver is supposed to survive this without glitching. Another thing you can do when you have the network emulator is delay one of the path. Let's say you delay the main. So now the main is received after the redundant stream. And your receiver is still able to receive the signal and recover it properly, even if you start dropping packet on the main and redundant. So it gets a little bit trickier, and some devices will fail if they do that. But that's something that's going to happen in real life in your lab. So it's important to know that your receiver can survive this and that the salesman wasn't, and that it actually supports -7. So now I'd like to talk about a bit is our experience at Matrox. being a vendor, we've been to all the JT&M tested event as a vendor. So we had to go and do all these tests at events and stuff. This latest event had a pre-testing for the event, where what we had to do is execute all these plans in our labs. And we were provided extra documentation to help set this up in our lab, because normally we just go to the event and they set up everything, we connect our device, and they know how to do the test, and they do the tests. But since now we had to do these tests in our lab, we needed a little bit of extra help to help configure our network properly and things like this, and to do some of the steps a little bit different. And so this is a bit of our experience for doing these tests. So for the SDP file validation, like explained, there's a program called SD Poker, for which you'll find a link in the test plan. And SD Poker, when you run it, you have to make sure you're running the right one. So throughout the years, it's been modified, and the one in the latest test plan, the 2020, is the one you should be using. It's been modified to have some extra tests and fix some bugs. And to install SD Poker on your system, you'll need to install Node.js, and you should be able to find instruction on the web on how to do that. But it's not too difficult. One thing that's interesting that I would like you to know is that SD Poker only generates an output if it finds a problem. And when I first ran SD Poker and tried to install it, that threw me for a spin, because I thought the thing wasn't working, because I ran it, did nothing.
Oh, gosh.
Okay, right? And it runs pretty quickly, so you're under the impression it's not doing anything. But what I ended up doing is taking my SDP file, modifying it, putting a real big error in it, run it, and then, what do you know? It told me you have error at this line, and then I knew my setup was good. So I suggest you do the same. Because SD Poker only checks the syntax. It doesn't check the content. It only checks if this is supposed to be a capital letter, it tells you if it's not. And if there's supposed to be a semicolon at the end of the line, it's going to tell you, hey, you're missing a semicolon. But it doesn't actually check that the IP address that's inside the SDP file corresponds to your sender. It doesn't. It only needs a sender. It doesn't know anything else, right?
Yeah.
So there's some extra things that we need to do to check for. So I have an example here for you. I know it's a bit of a alphabet soup, but what I'm trying to show you here is like, if you need to check what the multicast address of the signal is generating, and what resolution is the SDP file saying the signal is, you can look in the SDP file for this example. It's sending a multicast address 239.120.15.0. The IP address of the interface it's coming out of is 25.25.41.215. So you can check that. You can see that this is a 1080i signal, and it's interlaced, and it's 59 something, because it's not 60. That's actually 29, sorry. And then we can see that the reference clock that's used by this device is on, as the ID, the big string of number there, but it's on domain 127. Right. Then the other thing that we want to look at, if it's a -7 signal, is that it's properly described in the SDP file. So here, if it's a -7 signal, you should see a primary secondary reference inside the SDP file, with a section for the primary with the multicast address for that, and a section for the secondary. So if the secondary part is missing, but the device is sending -7, yes, it's sending -7, but the SDP file is wrong, and the manufacturer should fix that. And so another test that got added recently is the PTP Grandmaster Failover test. Based on a real-world requirement, like I was saying, people were complaining that they were purchasing devices that glitched when there was a failover. Now, the failover requires a little bit of a setup, so we actually had a document that explained how to do that, but it's actually not too complicated. If you have access to Grandmaster, good, it's a little bit simpler. Us at Matrox, we didn't have two Grandmaster in our lab. We had one Grandmaster, but there's a way to do this test using only one Grandmaster. So basically, if you have one Grandmaster and you have a boundary switch, you can also do this test and make sure the device will not glitch for you when you're doing failover. The basic concept is once you're all set up and your device is either sending or receiving a signal, you play with the priority of your Grandmaster so that one takes over the other one. So the way we did it with a one Grandmaster and the boundary switch is quote unquote slave to the Grandmaster. But we go in and we change the priority of the boundary switch to be a better priority than the Grandmaster. And it's just going to say, hey, I'm better than you and take over. And then, but this is on the network, does not generate a glitch, and devices should survive that without glitching. By the way, something that's a higher priority in PTP language is 1 is higher priority than 128. So basically what we do is we set the priority to 1, it takes over, it's the highest priority possible. And then when we're done, we put it back to what it was and it goes back, and then it shouldn't glitch either way. That's how you do that test. Next is a PCAP capture. So that's something you need to do in order to test your sender, is to be able to capture PCAPs. You may have a device that actually, or a piece of software that actually can capture PCAP, but because 2110 is pretty high bit rate, like if you're trying to capture a UHD signal, you need something that is very quick, can capture a vast amount of data in the PCAP file. It has to be a PTP link and be able to generate accurate timestamp, because that's how list looks. That's what list looks like in order to be able to measure the interpacket arrival time and all the magic thing it measures for verifying compliancy. And so you have to have a PCAP file that's accurate and has no drop frame and everything. And so EBU had provided us with instructions on how to build that if we didn't have one, because some manufacturers didn't have these devices and were complaining. So you basically take a computer, install Linux, put this specific network card that supports PTP. That's very important. Otherwise, the files are not accurate enough. And then they had a bit of a nerdy description of bits and bytes to change into the configuration of the network card in order to get it to work. And then, of course, that's where monitoring session comes in. You need to program your switch to copy all the packets that are coming from that device to send them to the device for capture. And then you capture a PCAP file that you can later on load in list. Maybe you already have a device that does PCAP capture, or make sure it supports PTP, because the data needs to be timestamped properly. The device may require you to do a monitor session, although if you're lucky enough to have a piece of equipment that's ST2110 aware that can also capture PCAP, it's probably going to just tell you which stream do you want to capture and be able to capture that. Although for this event, we wanted to verify -7 senders as much as possible. So you'll need to be able to capture a -7 essence at the same time as you capture the main essence. And so either capture those both into the same file or into separate file, that's fine. But it's very important that they're captured at the same time. They don't need to be frame accurate capturing at the same time, but there has to be a substantial overlap. Let's say you start the capture of one and then you start the other one, wait for a couple of seconds, then stop both. So the overlap is what will be looked for by list, and then the measurement will be done during the overlap. So what is list? List is that software that looks at those PCAP files that I just described and does all kinds of measurements to make sure it's compliant with the specs. It unfortunately requires very accurate PCAP file, so makes the device for capturing a little bit complicated. But it verified that it confirms to the spec. It's very easy to use. It validates a few other things, like multicast addresses have a specific MAC equation, and there's a way of building the MAC address for a multicast address that's very specific. They look for it. Some devices do it wrong, and then it causes havoc with switches. So running lists, there's an online version of lists, very useful, but not always practical, depending on your network environment. More about that later. But you can also install lists on a local computer. So you can build a computer, install Docker on it, which is a little bit tricky behind a firewall. In our case, that was difficult. So I recommend knowing a nerd that can help you do that part, maybe if your company is set up with firewall and you're having problem there. But once it's installed, it's very easy to use. All right, so this is what the screen looks like in list type thing. So for this example, list is saying the file I loaded in list is a 1080p file, and it looks at the signal and analyzes it. And at the bottom, we see a bunch of green square that say it passed all the tests. But if I had failed one of the tests, that square would be red. And then you can look in different tabs on top and pick the tab corresponding and go see what's wrong type thing. So that's basically that easy. So the other challenge is reference sender. So we talked a little bit about that before, but pretty early on while we were building the test plan, the expert group identified the need for a reference sender. So normally what we do is we go to the event, and at the event, the organizer already took a device, tested it, and decided that's going to be their reference sender. Now we have a bunch of companies wanting to participate that need to do the pre-testing in their lab. And so they need to identify their own reference sender, and they identify that it sends a valid signal and that it supports -7 if you need to do that type thing. So the problem in finding a good sender is that ideally you want a sender that's not perfect. That sounds a little bit funny.
Sure. No, that makes sense. That really does.
Yeah, because if you have a sender that's perfect and you're testing your receiver, well, you've proven that your receiver can receive a perfect signal. So for example, if you're using, say, an SDI to IP gateway, those have a tendency to generate gap and narrow signal, and very good signal because the SDI feed is very good. They turn around and IP it, and then it becomes a very good IP signal. And so you need to be able to generate a valid signal, but maybe simulate real life. And what I mean by that is, well, maybe real life, you have a sender that's actually a wide sender, or maybe it's a linear sender, not a gap one. So you need to be able to find those. Ideally for doing this test plan, you could find, and maybe you'll end up with a couple of reference sender, one for wide and one for linear and one for gap narrow. But also sometime in a real environment, you could have a device, let's say, that's listening to a camera directly, and the timing of the packets coming in or whatever the camera is outputting. But maybe the signal from the camera is going to like a device that does scaling and modifying the signal before it gets to your receiver. And of course, the timing will get affected by that. So it'd be nice to be able to simulate that in your environment. Or maybe also you need to take into account that sometimes your receiver will need to receive signal from many sources, or a source will be generating many signals. So instead of one flow going into your receiver, the sender is sending 32 flows all over the network, and you're receiving one of those. Well, the timing of that one will be different if the sender is sending one flow or 32 flow. And so it'd be nice to be able to affect the timing and simulate these things. Right. So our overall experience doing this at home is, for us, the online version of List did not work at all from Matrox. Maybe due to the fact that we're behind a firewall or anything. I tried it recently from my house and it was working, so it may work for you, but we ended up having to build a List system, and the Docker thing was a little bit of a issue for us, but eventually we got through it. PCAP capture definitely was a problem for us. We tried to build that Linux system with the card and everything, and it was still dropping packets sometimes. So you had to do a capture, load the file in, figure out, oop, there's drop packet, start over. That was our experience. Some other people had the same experience, yet some other people had no problem whatsoever, and they loved it, and it worked perfectly for them. So mileage may vary, just be aware of that. Seamless protection switching tests requires a bit of a complex setup, so that was a bit tricky. We were lucky because we had the same device that they used during the testing, so we're able to do those tests. But you may have to be imaginative to be able to do that part of the test. Definitely a switch capable of doing boundary and transparent and unaware was useful for us to do some of the tests. The boundary test for the failover test, the unaware, the transparent test was useful for us to do uh, other tests. We ended up developing our own reference source actually to help us do the tests. It enabled us to generate narrow and wide, linear and gap because it was hard to find devices that we could find that to do wide, for example. And it turned out to be simpler to just build up something. We managed to put in some tweak in there to simulate stuff like delayed in the signal and things like this. So we were planning on bringing the device with us to the tested event. Unfortunately, because of COVID, the tested event got canceled. But people still ask us to make it available to the industry, which we decided to do. So if you're in need of a reference sender, you may contact Matrox. It has a few little interesting things that could be useful. And so basically that's our experience with the tested program. I suggest it's a use if you're going to do tests. If you already built something, you might want to look at the tested program to see if you missed anything. Some of the tools in there might be useful, even though you have your own testing program. And if you think of building one, I think starting there would be a good idea.
Well, thanks a lot for that. Appreciate that was a lot of really good information. I did have just digging a little bit deeper into that
Mm-hmm.
testing. Is where you're talking about having to have a source where it wasn't perfect. It could actually explore the limits of
Yeah.
going all the way from just barely good to just barely bad.
Yes.
Um, is that something that people are going to be able to get in the near future? Is that something that's coming out soon?
Uh, yes, the device that Matrox developed, it's called Vero. Basically lets you generate a perfect signal and then tweak the value so you can make it, a little slower than normal, or it goes at the edge. It lets you generate a white signal and then make it so that it uses one of the things list measure is called VRX buffers and stuff like that.
Yep.
And in the spec, it says you need to be within this number, you're narrow. And if you go above this number, but below that number, you're wide. And if you go above that, you're not legal type thing. So this kind of testing device lets you play with the value so that you end up with a wide signal versus a narrow one. And you can do things like simulate a delay through your network where your video is going to be delayed with respect to your audio and so many
Mm.
microseconds type thing. So it simulates a device in the middle doing some scaling and something and respitting the signal after type thing. So yeah, that type of things.
That sounds
Yes.
pretty useful. So the other question I had was, what do you see changing in the tests going forward? Right? What do you see happening to the test plans and what people are going to be having to do over the next year or two?
Yeah. So that's an interesting question because even before COVID happened, there was already discussion of, these tested event, like everybody has to travel to one place and bring
Mm.
equipment and people and support to set up this big network. Like you think of these, the industry is setting up 2110 infrastructure and they're doing this build and they install all this equipment and they take months to do that. We do that in a day and a half, right? We bring
Yeah.
a lot of equipment, connect it to a network, build it up, generates the signal, everything flows nice, and you build that in a day, day and a half, and then you do a bunch of tests. And so it's a big challenge. A lot of people going there, money, shipping all the
Mm-hmm.
equipment, everything. So people were already saying, well, these face-to-face event, we need to find a better solution. And then COVID happened, right? And then we
Mm-hmm.
couldn't even do the face-to-face. But some of the tested plan, like the ISO 4, ISO 5, they were able to do that because they set up VPN network and the device were not brought to the network. The network was brought to the device and they were able to do some tests. So I think the next best thing is to figure out how to do these tests without having to bring people and equipment all together in one room.
Well, that'll be I guess that'll be more convenient for everybody, but not as much fun. I've been to one or two of those, and it's certainly an interesting time. You learn a lot about what everybody else is doing, but
Yes, yes, it's interesting. It can be fun maybe on Thursday night, but it's not so
yeah,
fun on Sunday
yeah.
night.
Hey, it can be a little stressful. I do admit that. Do admit that.
Yes, yes.
All
I
right.
think that, I think to help those things too, these the having a device that can do the reference sender, obviously, but
Hmm.
also capture, standardizing that, and providing something like a one-stop shop if you want, so everybody has access to the same thing. That's probably also going to help that issue.
Well, that makes sense. Well, thank you very much for your time. That was a very interesting presentation.
Thank you for having me.
I appreciate
And,
it.
good
So,
luck for the test plans.
yeah, test plans are fun. So, are you getting? Do you have any scheduled time off this summer?
Yes, I do. In the end of July, there I'll take a few weeks off.
Are you going to leave your house?
Yes, we're gonna leave the house, but maybe for day trips instead of going to Italy or anything like that, right?
Yeah. Europe isn't even letting Americans in right now.